Okay, good morning to everybody. Today we are going to discuss about an expression for de Broglie's wavelength. An expression for de Broglie's wavelength. You know what are matter waves? The definition for matter waves given by de Broglie. Material particles associated with wave is known as matter waves or de Broglie waves. For the wavelength we use two equations. First one is according to Planck's theory, according to Planck's quantum theory. According to Planck's quantum theory, energy of the photon is given by E is equal to h nu. Is equal to nu is the frequency. So E is equal to hc by lambda. This is equation 1. And another equation, Einstein's mass energy equivalent relation. Einstein's mass energy equivalent relation. E is equal to mc square. This is equation number 2. From these two equations can derive the wavelength for de Broglie waves or matter waves. First equation, E is equal to h nu, that is equal to hc by lambda, and another equation, E is equal to mc square. From these two you can equate hc by lambda is equal to mc square. From this, lambda is equal to h by mc. Here mc is the momentum of the photon. Suppose we consider a particle of mass m and velocity v, then its momentum. The velocity v and mass m, then momentum is mv. The de Broglie wavelength for the particle, wavelength lambda for particle. Wavelength lambda for particle, lambda is equal to h by mv. Okay, now this is an expression for de Broglie's wavelength. This is derived from two equations. One is Planck's quantum theory. From this theory, energy of photon is given by h nu. This is equal to hc by lambda. And another equation, Einstein's mass energy equivalent relation. From this, E is equal to mc square. From equation 1 and 2, hc by lambda is equal to mc square, then lambda is equal to h by mc. This is the de Broglie's wavelength lambda. And now let us know different forms of the de Broglie's wavelength. First one is, if E is the kinetic energy of the particle, E is equal to half mv square. This is equal to 1 by 2 m square v square by 2m by m. How it is written? By multiplying m and dividing. From this, m square v square is momentum square. Momentum is denoted by the letter, so m square v square is p square by 2m. Then p square is equal to 2me. P is equal to square root of 2me. Look at the equation. This is lambda h by mv. Here mv is the momentum. Momentum is denoted by the letter p. So first form of de Broglie wavelength lambda can be written as h by, in the place of p, mv, write square root of 2me. This is one form of de Broglie's wavelength. When E is the kinetic energy, then lambda is equal to h by square root of 2me. Now another form of de Broglie's wavelength. If the particle having charge q and it is accelerated by the potential difference v volts, then energy of the particle E is equal to q into v. Energy is equal to q into v. Now we substitute in the place of E in this equation 2 or 3. Let us suppose this is equation 3. Now lambda becomes h by square root of 2m, instead of E write q into v, qv. This is another form of de Broglie's wavelength. Now discuss another form of de Broglie's wavelength. In this case, first E is the kinetic energy. In the second case, when particle is a charged particle, that means if it is having charge q and it is accelerated by the potential difference v volts, then the energy on the particle is q into v. This is the second case. The third one is another form of de Broglie's wavelength. When the particle is in thermal equilibrium state, energy of the particle is equal to 3 by 2 into k into T, where k is the Boltzmann constant, T is the temperature. Now substitute lambda is equal to, in the place of E, h by square root of 2me, in place of E substitute 3 by 2 kt, h by square root of 2 into 3 by 2 k into T. 2 cancelled, and then here m. Now h by square root of 3 mkt. This is also another form of the de Broglie's wavelength. In this case, particle is in thermal equilibrium state. Now these are different forms of the de Broglie's wavelength. Now discuss about the properties of matter waves. Properties of matter waves. Matter wave has different properties. Now first property, when the wave is associated with lighter particles, it has a greater wavelength. If the mass is small, m is small, wavelength is lambda is great value, high value. If second property is, if the particle's velocity v is small, lambda is high value, that means great value. These are the properties you can remember, you can easily understand by knowing this formula h by mv. Here m is the mass, v is the velocity. When these two quantities are small, then lambda will be great value. Then third property is, matter waves are generated by the moving particles. How can we know this property? If v is equal to 0, lambda is equal to infinity. Okay, if v is equal to infinity, lambda is equal to 0. That means v must have certain value, then only it has wavelength and wave properties. So these type of matter waves are generated by the motion of the particles. The particles are either charged or uncharged. Okay, so electromagnetic waves are the charged particles. But whereas matter waves are not charged particles, either charged or uncharged. These matter waves are independent on the charge of the particles. Fourth property is, velocity of matter waves depends on velocity of particles, velocity of particles. Whereas electromagnetic waves, the velocity is constant for electromagnetic waves. But in the case of matter waves, velocity depends on the velocity of the particles. Okay. Now, fifth property, velocity of matter waves is greater than the velocity of light. Velocity of matter waves, suppose this is represented by the letter W, is equal to c square by v. W is equal to c square by v. This equation can be derived by two equations, that is Planck's quantum theory h nu, tarvata Einstein's mass energy relation A is equal to mc square. From this equation, nu is equal to E by h. From these two, nu is equal to h nu is equal to mc square, nu is equal to mc square by h. W is the velocity of matter waves. This is equal to nu lambda. Nu is mc square by h. Nu is equal to mc square by h. And lambda is equal to Debroglie length h by mv. Here m is cancelled, h is cancelled. W is equal to c square by v. Here c is the velocity of light and v is the velocity of the particle. As velocity of the particle never exceeds the velocity of light. So from this equation we can say the velocity of matter waves are greater than the velocity of light. From this we conclude that the velocity of matter waves W is always greater than the velocity of light. And the sixth property is the wave property, the wave nature and particle nature cannot appear simultaneously. That means we cannot see the same two properties, that means wave property and particle nature in same experiment. Okay, so these are the properties of matter waves. If the matter waves are associated with lighter particles, that means mass is small, and if the velocity is small, then that waves has greater wavelength, and the matter waves are generated by the moving particles. The velocity of matter waves depends on the velocity of the particles. And fifth property is the velocity of light is smaller than the velocity of the matter waves. That means velocity of matter waves is always greater than the velocity of light. W is the velocity of matter wave is greater than the velocity of light. And last property is you cannot see the two properties. That means the wave nature and the particle nature cannot appear in the same experiment. Okay, thanks to everyone.